Hi all, welcome to my channel. This is Yunus. Today we are going to discuss about DynamoDB table and how do we calculate the read capacity unit RCU. Okay, let's begin. Before we understand how to calculate the read capacity unit, we need to understand another concept related to DynamoDB table, which is the consistency. There are two consistencies, which is strong consistency and eventual consistency. Let us try to understand what it is. As you already know, DynamoDB table automatically replicates the contents of the table to two other availability zones, or in total in 3 availability zones the table will be replicated. Now assume that a user or application is writing or updating something in availability zone 1. That has to be propagated to availability zone 2 and 3. It will take a few milliseconds or less than 1 second. But what if somebody else tries to read the same item or the same record before the changes are propagated to the other availability zones? That is what is shown here. This color shows that it is updated here, but it is not propagated to availability zone 2 and 3. So when a user or application is trying to read from the table, there are two ways in which you can read from the table: eventually consistent read or strong consistent read. Eventually consistent read means that if you are trying to read from availability zone 3 and the propagation is not yet complete, that is called eventual consistency, because there will be slight discrepancy between the data in availability zone 1 and availability zone 3 at that time, but eventually within a few milliseconds it will be updated. So you are going for eventual consistency when the data is not very critical. Data is of course important, but it is not very critical if there is slight mismatches. In such cases you can go for eventual consistency. So if you are okay to allow readers to read an item before an update is propagated to all availability zones, you can choose eventual consistency. But there are cases where, say, it's a flight booking system, and if somebody has already booked a particular ticket, that should be updated in all the other availability zones so that there won't be any double booking done. For that scenario, we need to use strong consistency. In case of strong consistency, the read operation will wait till the propagation is done. You can see that here. If you want to allow reading of an item only after the propagation is done, you can choose strong consistency. So these two are important because the effort, the reading effort or the compute effort required for eventually consistent read is almost half of a strong consistent read, because here you have to wait for some time. Okay, now the read capacity unit required for reading differs in both cases. That is why we saw this particular concept before we got into RCUs. Okay, let's begin with discussion on RCUs or read capacity unit. So RCU is the computing effort required to read a block of 4 KB data. Assume that an item is a record or one row in DynamoDB. If one item is 4 KB or less, that can be considered as one single block, and the computing effort or the number of computing cycles, CPU cycles required to read a block of 4 KB data is known as one RCU. In case of strongly consistent reads, to read a 4 KB data per second, you need one RCU. Okay, that is the definition. Or if you have 2 KB data, that is also considered as a single block, so then also you will need one RCU. In case of eventually consistent reads, to read 4 KB data per second, you only need 0.5 RCU. That means if your capacity allocated is 1 RCU, you are able to read 2 units of or 2 blocks of 4 KB data per second. Just to give more clarity, if you have 1 RCU capacity allocated to your table, then you can read 2 blocks of 4 KB data per second if you use eventual consistency, but if you use strong consistency, you can read only 1 block of 4 KB data per second. Okay, let's move on. Again, to give more clarity, in case of eventual consistency, 1 RCU allows you to make 2 reads per second for item up to 4 KB in size. It's a kind of a repetition in different words of what we discussed in the previous slide. And all these points are for eventual consistency. If the item size is 4 KB, you can do 2 read operations per second. of course, because you need only 0.5 RCU to read a 4 KB block. And if an item is of size 8 KB, you can do 1 read operations per second. And all these points are assuming that your capacity allocated is 1 RCU. If the item size is 3 KB, it is considered as one full block of 4 KB. So you will need 0.5 RCUs to read that. And if the item size is 6 KB, that is 2 blocks. So you will need 1 RCU to read this block of 6 KB because that is 2 blocks. So that was about eventual consistency. Now let us see strong consistency. Assume that in strong consistency the allocated RCU is 1 RCU. So what are the things possible? 1 RCU allows you to make 1 read per second for item up to 4 KB. If the item size is 4 KB, you can do 1 read operations per second. But if the item size is 8 KB, you will need to request 2 RCUs. You will need to allocate 2 RCUs to your table so that you can read 8 KB data in 1 second. Otherwise, it will take 2 seconds. If you have an item size of 8 KB and you have only 1 RCU, then you will need 2 seconds to read this item. And if it is 6 KB, again it is 2 blocks. So 8 KB and 6 KB is considered same. You will need the same number of RCUs. That's about strong consistency. Now we have a few problems. Let us see the first one. The item size is 31 KB. Item is one row in DynamoDB table. It is 31 KB. You expect to read one item every second. The application is going for strong consistency read. How many RCUs are required? So first you calculate how many blocks are there. It is 31 KB. Which means that if you divide it by 4, you will get 8. I know it is 7.75, but you have to round it up. So 8 blocks of 4 KB data is there. Because it is strong consistency, you will need 1 RCU for 1 unit of 4 KB. So here there are 8 blocks, so you will need 8 RCUs. So that's what is shown here. Data size is 31 KB, 8 blocks of 4 KB. Strong consistency indicates that you will need 1 RCU per block of 4 KB, which indicates that you will need 1 RCU per block. So 1 RCU into 8 RCUs are required in this particular case. Now let us see the second one. Here data size is 71 KB, but you are going for eventual consistency. So how many RCUs are needed? So 71 KB means that we have 18 units or 18 blocks of 4 KB data. Okay, 18 blocks. 18 into 4 is 72. So 18 blocks. And each block requires 0.5 RCUs. So you will need 18 into 0.5, that is 9 RCUs here. Calculation is shown here, 18 blocks of 4 KB. Eventual consistency indicates that you will need 0.5 RCU per block. So 0.5 RCU into 18 blocks equal to 9 RCU. Okay, so that is second problem. Now the third problem, slightly complex. As a senior architect, you are responsible for maintenance of your database applications written using NoSQL or basically DynamoDB. A new project demands a throughput requirement of 10 strongly consistent reads per second. So basically the item size or data size is 6 KB and your application needs to read 10 such blocks in a second. That's what it means, 10 strongly consistent reads per second of 6 KB in size each. How many RCUs will you need? So let us try to calculate that. So 6 KB means 2 units. Okay, it is 2 units, 2 blocks. And it is strongly consistent, which means that per block you need 1 RCU. Since there are 2 blocks per data and there are 10 such data pieces, so you will need 10 into 2, 20 RCUs. Let us see the calculation. For strong consistency, you need 1 RCU per block of 4 KB. If you have 6 KB size, that is 2 blocks. So you need 2 RCUs per data block. Since you are looking for 10 read per second, you will need 10 into 2 equal to 20 RCU. Now we will have one more question and then we will close. So here, as a full stack developer, you are involved with every aspect of a company's platform, from development with PHP. All these are setting the context. The real question is here, you are concerned about your response receiving stale data from your database and need to perform 16 eventually consistent reads per second of 12 KB in size each. So 16 eventually consistent reads per second of 12 KB. Okay. So how many blocks are there? There are 3 blocks. Per item you have 3 blocks. and 16 such items are there. So totally you have 16 into 3, 48 blocks are there. And per block you need 0.5 RCUs because it is eventually consistent. So the calculation is 16 into 3 blocks per data piece. So that is 16 into 3 equal to 48 into 0.5 RCUs. So that is 24 is the answer. So you can see that calculations here. 1 RCU equal to 2 eventually consistent reads per second for an item up to 4 KB. Hence for 8 KB data, 1 read will cost 1 RCU. For 12 KB it will cost 1.5 RCU. Since you are looking for 16 reads per second, it is 16 into 1.5 equal to 24 RCUs. Okay, I hope you were able to understand how the RCUs are calculated. I'll definitely do another video about write capacity unit calculation. Please let me know your comments and questions. Thank you. Bye.